Now let's look at how we can actually use the unit circle to answer various questions. Okay, so here's the first question. Sine theta equals minus 3 over 4, and theta is somewhere between 3 pi over 2 and bigger than pi. Find cos theta and tan theta. So what we're going to do is this, we're going to work out what cos theta and tan theta is going to be without actually using the calculator at all. Okay, we're just going to use the fact that they've told us what sine of the angle is. It's minus 3/4, and the size of the angle. It's between these two parameters. The unit circle is going to help us do all of that. So let's just draw a little diagram to help us visualize this. Here's our unit circle. Oh god, I need to practice drawing circles. Oh my god, that's even worse. Right, that's actually not too bad. Right, right. First of all, let's label our axes: x, y, and this would be 0 degrees, radians. Let's stick to radians because they give us it in radians. Pi over 2 would be here. Pi would be here. 3 pi over 2 would be down here. Again, that will be here. Right, so it's telling us the angle is somewhere between this one and this one, so it's down here. Now what I want you to think about is this. Yes, we're trying to find out cos of an angle and tan of an angle, but also trying to think about what we're actually doing in terms of the unit circle. We're trying to find out this this coordinate, really, and it's telling us that sine theta part is minus 3/4. So this part here is telling us there's minus 3/4 down here. Okay, so that's minus 3/4 there. Actually, I need to maybe draw this a little bit bigger. That's minus 3/4, and so it's down here, and the angle is somewhere between these two values. So it's this angle here, bigger than 180 but less than 270. So all we really need to do is find cos theta, and then remember tan theta, we can, once we've got these two, once we've got sine and cos, tan theta is just the division of the two of them, isn't it? It's just sine theta over cos theta, right? Okay, so we're actually trying to work out this position, this coordinate, and we know this part already. We know the y part is minus 3/4. We really just need to know the x part, the cos theta part, and then we can work out tan theta as well. Now, I'm going to do it slightly different to the way it's done in the book. Someone showed me this particular method, and I found it really easy to use this particular way to work out these two here. What we're going to do is this. We'll draw a random right angle triangle like this. Okay, this is our working out triangle. Okay, this is not really anything to do with any triangle we can make in here really, but this is our working out triangle. And let's say this is the angle of interest, and this will be the opposite, this would be the adjacent, and then this would be the hypotenuse, right? Okay, and this is our angle of interest. And alright, if we think about Sohcahtoa, okay, so let me write that bit again. Sohcahtoa. Right, we're told what sine theta is. Sine theta is minus 3/4, but sine theta is also the opposite divided by the hypotenuse, right? Sine theta equals the opposite divided by the hypotenuse. But it's telling us that the opposite, really, well, we can use these numbers here, and I know it doesn't quite make sense, but let's just use these numbers here anyway. So opposite over hypotenuse is telling us that the opposite is minus 3, and the hypotenuse is 4, right? Okay, opposite divided by hypotenuse. This is now just our working out triangle. Based on this angle, opposite and hypotenuse. Okay, and because it's a right angle triangle, by Pythagoras, we can work out the adjacent, right? A squared plus b squared equals c squared. So we would have to, well, we've got the c part really. It's the a, well, it's the one of the shorter sides we're missing. So we'll have to do 4 squared minus 3 squared square rooted. Okay, well, that would be 16 take away 9, which is 7. So this would be, this side would be root 7. Okay, sorry, root 7. Okay, we'll leave it in surds. Remember, we're not using the calculator at all. So this side's root 7. So we've got all the sides now. Well, actually, what we can do now is work out what cos is going to be based on this triangle. Well, what's cos theta? Cos theta is going to be the adjacent divided by the hypotenuse, root 7 over 4. Okay, root 7 over 4. Now, but here's the problem though. We can't just leave it at root 7 over 4, because what we need to do is check whether it is that particular answer. Now, going back to our circle, remember on our last clip we looked at how to label this circle. Remember, it's all silly turtles crawl. This helps us determine what's positive where. So if the angle was in this region, then whatever sine, cos and tan will all be positive, and only sine will be positive here, and only tan is positive here, and only cosine is positive here. Right, so our angle here is in this quadrant. That means this one's going to be the positive one, the other two have to be negative, right? And it kind of makes sense. Now, if you think about it, what we have here is we have a positive root 7 over 4. So if we start at the origin, remember the coordinate is cos theta, sine theta, but if our x component is root 7 over 4, that means from the origin we're going, root 7 and 4 will be somewhere about here. We're going this way, and then we'll go down minus 3/4, right? Because they've already told us the y component is minus 3/4, right? We already know that. So we would go along and down if it was root 7 and 4. But the thing is though, we're not. Our coordinate's over here. It's to the left. So that must mean that cos theta must be minus root 7 over 4. So we need to stick a minus in front of that, because we're going from the origin, we're going left and down here. And like we said, well, we know it's got to be negative because it's in this quadrant here. Remember, it's all silly turtles crawl. We're in this quadrant, only tan's positive. So the cosine theta has to be negative. So we've got the following things now. We've got sine theta is minus 3/4, and cosine theta has to be minus root 7 over 4. It has to be that, because we're going left and down from the origin. Okay, right, now all that's left is to work out tan theta. Now, there's two ways to do it. We could divide these two, and maybe we'll do that in a minute. Or we could just go to the triangle and work out tan theta, right? Because we haven't done that yet. So, well, let's do it with the triangle first, because it's there and it's easy. So, tan theta is the opposite divided by the adjacent. Well, the opposite is minus 3, according to this triangle, over the adjacent, which is root 7. Now, the thing is, though, we discussed that if it's in here, tan theta has to be positive, right? It has to be positive. So what we need to do is just rub out that negative sign here. So tan theta has to be 3 over root 7. Okay, it has to be 3 over root 7. But let's just double check that using these two here. So we've used the triangle to work out tan theta has to be 3 over root 7. And the fact that if the angle's bigger than 180, less than 270, that only tan of it's going to be positive. So, but let's use these two to work out the same answer, right? Okay, now remember that tan theta equals sine theta over cos theta, right? That's the rule, yeah? Okay, that's the identity we looked at in one of our clips. So we know that it's going to be minus 3/4 divided by, okay, I'm just doing it this way because it's easier to see, minus root 7 over 4. Now here's the thing, we're going to do a negative number divided by another negative number, so our answer is going to be positive straight away. Two negatives divided give you a positive, so our answer is going to be positive, right? So far so good, because we've got positive here. Now remember how you divide fractions, you keep the first one the same and you change it to the sign and you flip the other one, 4 over root 7. Right, okay, the 4's cancel out, so we're left with positive 3 over root 7, which is the same thing as here. Right, so just by rubbing out the minus sign that we had here, we got that tan theta is 3 over root 7. So without using a calculator, we've just worked out what cos and tan of a particular angle is without even knowing what the angle is. We don't actually know whether it's 190 degrees or 250 degrees. All we know is somewhere bigger than 180 but less than 270, and we worked out exactly what cos and tan is going to be. Okay, now let's just do one other one. Okay, so example 2, try and keep this under 15 minutes. Okay, so let's go through it quickly. tan theta equals -2. Okay, so we're told tan theta equals -2, and the angle is somewhere between 2 pi, okay, 360, and 3 pi over 2, that's 270. So if we take our unit circle, okay, all silly turtles crawl, that's the way to remember it. It's somewhere down here, so our angle is a very large angle like this. Okay, so starting from here, going all the way around, that's the angle. Now, let's draw a working out triangle. Okay, this is our working out triangle. Okay, and let's say this is the angle of interest, opposite, adjacent, hypotenuse, and adjacent, right? Okay, now what it's telling us is tan theta, let's write down Sohcahtoa. Again, tan theta is the opposite divided by the adjacent, but all we've got is -2, okay? Now, I need to try and make a fraction somehow with this, okay, because I need to say opposite divided by adjacent, right? I need to try and make a fraction somehow. But what can I stick this over then? That doesn't change it. Well, I can put it over 1, right? -2 over 1 is just the same as -2. So what is it telling us now? That -2 is the opposite. Okay, that's -2, and the adjacent is 1. Okay, now doing a bit of trig, 1 squared plus -2 squared, and then square rooted. Okay, that's going to be 1 and 4, and then square root that. The hypotenuse is √5. Okay, now let's work out cos. Let's work out sine and cos. Right, sine. So we've got all the sides. That's √5. That's -2. That's 1. Right, sine is opposite divided by hypotenuse. Opposite is -2. So sine of theta. Oops, let me do it again. Sine of theta is opposite, which is -2, divided by the hypotenuse, which is √5. Now, let's just double check the sign of it, right? Okay, because it might not be a minus, it might be a plus. Right, so what do we have here? It's in this quadrant, so only cosine is positive. Okay, remember you're effectively working out the coordinate here. Cos theta, sine theta, to go along and down, that needs to be negative. So what do we have? That's negative, okay, so that's fine. So we don't need to change it. So sine theta must be 2 over √5. So that's the first one, right? Cos theta. Okay, we already discussed that cos needs to be positive because starting from the origin, we're going along and down to get to this coordinate, so that needs to be a positive answer. All right, cos theta is adjacent over hypotenuse. The adjacent is 1, and the hypotenuse is √5, so we're going to do 1 over √5. Okay, and that's a positive number, so we don't need to change it. There we go, didn't need to do anything with that. So without a calculator, we've just worked out what sine of that really big angle is, and what cos of that really big angle is as well, without touching the calculator at all. Okay, it's going to be -2 over √5 and 1 over √5. And that's really it, really. Okay, there's nothing much more than that. The next examples, we're going to look at using some trig ratios and this unit circle as well, okay?